Today we're going to learn about graphing linear inequalities. Graph the boundary, use a test point, and shade the half plane. So when we have an equation like x is greater than 2, we can pinpoint the value of 2. Now the inequality doesn't include the value of 2, so it's going to be a dotted line instead of a solid line. Now x can only include all the values greater than 2, so it's going to be 3, 4, 5, 6, and etc. Let's use a test point. So we've graphed the boundary, now we need to use a test point. So let's try a value of 3. If we plug in 3 for x, we're going to have 3 is greater than 2. And this checks out. So we know that the right hand side of the boundary includes all the values greater than 2. So we can shade it in. When graphing linear equalities, the only additional step you need to make is shading in the side of the plane that's included in the inequality. Now for the second one, we're already given it in slope-intercept form. We have y is less than or equals to 2x plus 1. Where's the y-intercept? It's at 1 here. Let's put a point at the y-intercept. And the graph increases with a slope of 2. And notice how the inequality symbol is a less than or equals to. So it includes the value, which means the line is going to be solid and not dotted. So we've effectively graphed the boundary. Now let's use a test point. Now normally for a test point, you actually need to test utilizing an ordered pair. This means we need a value of x and y. So let's say we have a test point of 0, 0. If we were to plug that into the equation, we'd get 0 is less than or equals to 0 times 1 plus 1, which is going to be 0 is less than or equals to 1. And this is true. So our test point is at 0, 0, at this point right here. And it was fulfilled. It worked. So we put a check mark, and we know that this point is in the correct half plane, so we can confidently shade in this side of the plane, since this side of the plane is the solution for the linear inequality. Now let's try this last problem here. We need to first transform this into slope-intercept form. So let's subtract 3x from both sides. So we're going to get negative y is less than 2 minus 3x. Now we need to divide by negative 1. And remember, the inequality is going to flip here. And we're going to get negative 2 plus 3x. So we're going to get y is greater than 3x minus 2. So let's graph this. So the y-intercept is negative 2. So here's the point. And the slope is 3. So the line is going to be dotted because the solution has to be greater than the linear equation. Let's try a test point now. Let's try 0, 0 again. 0, 0 is always a great test point to use. It's almost always going to be on one of the half planes. So if we plugged in 0, 0, we're going to get 0 is greater than 3 times 0 minus 2, which is going to be 0 is greater than negative 2. And this is true. So this means that the point 0, 0 is included in the solution. We can confidently shade the side of the half plane.